The James Webb Space Telescope has rapidly become humanity's most powerful eye in the cosmos. A marvel of engineering and science, it was launched not just to observe stars and galaxies, but to change the way we understand our place in the universe. Its mission goes far beyond simple observation. It aims to probe the mysteries of our solar system, scan the atmospheres of distant exoplanets, peer into the origins of galaxies, and even search for signs of life beyond Earth. And now, it has delivered a discovery that has left scientists both thrilled and deeply puzzled. In a recent and highly anticipated observation, scientists pointed the Webb telescope at a star located about 120 light-years away in the constellation Leo. What they found was nothing short of astonishing. Orbiting this star is an exoplanet known as K218b, and for the first time, Webb has detected carbon-based molecules in its atmosphere. Potential signs that this world could host an ocean beneath a hydrogen-rich sky. This discovery is more than a scientific milestone. It could mark a step closer to answering one of humanity's oldest and most profound questions. Are we alone in the universe? Welcome to Discovery at 2.0, where we explore the breakthroughs that are changing the way we view the cosmos. Join us as we unravel the mysteries of this distant world and the secrets hidden in its atmosphere. The planet K218b is no ordinary exoplanet. Discovered during NASA's K2 mission, it was first flagged as a transiting planet, meaning that it dims the light of its host star slightly each time it crosses in front of it. This dimming provides scientists with a rare opportunity to study the planet's atmosphere as starlight filters through it, revealing spectral signatures of the gases present. But it wasn't until the James Webb Space Telescope aimed its instruments at K218b that the true nature of the planet began to come into focus. Using its near-infrared spectrograph, NIR spec, Webb has detected methane, CH, and carbon dioxide, CO, in the planet's atmosphere. These carbon-bearing molecules are considered crucial indicators of planetary processes, and on Earth, they're closely associated with life. K218b is about 8.6 times the mass of Earth and 2.6 times its radius, putting it in a class of planets sometimes called sub-Neptunes, larger than Earth, but smaller than Neptune. Interestingly, this category of planet is not found in our solar system, making them all the more intriguing. Sub-Neptunes like K218b are believed to have thick atmospheres, possibly covering vast oceans or high-pressure ice mantles. Previous data from the Hubble Space Telescope hinted at a hydrogen-rich atmosphere on K218b, but Webb has provided confirmation, and more. It now appears that this planet may be a type of world referred to as a Hycean planet, one that has a rocky or icy core, enveloped by an ocean and a hydrogen-rich atmosphere. This combination could offer conditions suitable for life, especially microbial life, similar to Earth's earliest oceanic ecosystems. What makes this discovery even more compelling is the possible presence of dimethyl sulfide, DMS, a molecule that, on Earth, is only produced by living organisms, especially by phytoplankton in marine environments. On our planet, DMS is considered a biosignature gas, a chemical fingerprint of life. While the DMS detection on K218b is still tentative and requires confirmation, the fact that Webb has reached a sensitivity level capable of even suggesting its presence is an incredible achievement. Scientists are cautious, however. While the presence of methane, carbon dioxide, and possibly DMS is exciting, it doesn't automatically confirm life. There are non-biological processes that can also produce these gases. What gives researchers hope, though, is the absence of ammonia in the atmosphere, a factor that supports the idea of an ocean world rather than a gas giant or frozen mini-Neptune. Dr. Niku Madhusudan, an astronomer from the University of Cambridge, has emphasized that while K218b lies within the habitable zone, the sweet spot around a star where temperatures might allow liquid water, it still may not be truly habitable in the Earth-like sense. Its size and mass suggest that it likely has a deep, high-pressure water layer similar to Neptune's icy mantle. This means that even if an ocean exists, it may be under extreme conditions that are very different from Earth's. And yet, the prospect is thrilling. The Webb telescope has given us the most detailed spectrum to date of a habitable zone sub-Neptune, allowing researchers to identify key molecules and assess the planet's atmospheric chemistry in unprecedented detail. This is just the beginning. The next step? Scientists plan to use Webb's mid-infrared instrument, MIRI, to probe deeper into the planet's atmosphere. MIRI will help confirm whether DMS is truly present and provide greater clarity on the planet's temperature, cloud cover, and potential weather patterns. It's a massive leap forward in the search for life beyond Earth. But K218b isn't the only place where Webb has pushed the boundaries of science. In another groundbreaking observation, the telescope detected complex organic molecules, technically known as polycyclic aromatic hydrocarbons, PAHs, in a distant galaxy called SPTO 41847. These molecules are found in soot, petroleum, and smog on Earth. But here's the incredible part. The light from this galaxy began its journey just 1.5 billion years after the Big Bang, meaning these complex molecules existed in the early universe, when it was just 10% of its current age. The presence of such large and complex molecules, some with dozens or even hundreds of atoms, in such a young galaxy defies what many cosmologists expected. Previous models assumed that the chemistry required to form these molecules would take billions of years to evolve. But here they are, early, widespread, and mysteriously non-uniform in distribution across the galaxy. Why they're clumped in certain regions and absent in others remains unknown, opening up even more questions about the nature of cosmic evolution. To give context, our Milky Way galaxy is around 13.6 billion years old, and the universe itself is about 13.8 billion years old. Yet the galaxy SPTO 41847, though only a fraction as old, is already as massive as the Milky Way and contains similar levels of carbon and oxygen, elements essential for life and planetary formation. How such a galaxy formed and chemically matured so quickly is a mystery that challenges existing theories of galaxy development. What makes this all possible is Webb's unmatched sensitivity and resolution, which allows scientists to observe faint signals and subtle details never before visible. For the first time, we're not only detecting the presence of molecules in far-off galaxies, we're mapping where they are, how they behave, and what they might mean. Each new observation brings us closer to understanding the building blocks of life and how widespread they might be in the cosmos. Whether in the atmosphere of a nearby exoplanet or the swirling gases of an ancient galaxy, organic molecules seem to be far more common than we once imagined. This raises profound questions. Could the seeds of life be scattered across the universe? Could the building blocks of biology be a universal phenomenon rather than an earthly rarity? As humanity stares deeper into space than ever before, we are witnessing not only the universe's ancient past but perhaps the first glimmers of other worlds that resemble our own. And with the Webb telescope expected to operate for many years to come, we can only imagine what new secrets it will reveal. At Wave's Discovery, we believe these findings represent more than data. They are signposts in a journey toward cosmic understanding. As scientists, dreamers, and explorers, we are witnessing the very beginning of a new era in astronomy, where the question of life beyond Earth is no longer speculative, but a target of focused and powerful investigation. Let us know your thoughts in the comments. What do you think about K218b and the presence of carbon molecules in ancient galaxies? Could we be on the verge of discovering alien life, or at least, alien oceans? If you enjoyed this exploration and want to stay up to date with the latest space discoveries, be sure to subscribe to Discovery at 2.0 and turn on notifications. The universe is vast, mysterious, and filled with wonders, and we're here to uncover them, one discovery at a time.